What is the variable for force in raw equations? That's going to be the capital F. As in the equation F equals ma, that F stands for force. What is the unit that comes after the numbers of force? That's going to be called the Newton, which is capital N. That's the metric unit for force. For the English unit, that'd be pounds. We measure things with either so many pounds of force or so many newtons of force. What's the variable for acceleration in raw equation? That's the letter A. Again, as in the equation F equals ma, or A is equal to delta V all over T. In these cases, we call those raw equations, and that variable stands for the acceleration. A is the answer. What's the unit for acceleration? That's meters per second squared. The variable for mass is a little m, and we measure mass in kilograms for the metric system. Newton's first law says an object will keep its present motion. Keep its present motion until acted upon by a net force. So if it is stationary, it's going to stay stationary until there's a net force. Circle the word net to make an emphasis there. If it is moving north at 50 miles an hour, it's going to stay moving north at 50 miles an hour until a net force hits it. Newton's second law says that force equals mass times acceleration. That's also known as F equals ma. An old-fashioned version of Newton's third law is that for every action there is an equal and opposite reaction. Now that's an old-fashioned way of using it. Back when Newton was living, the word reaction had a different meaning than it does today. So let's look over here at number 20 for a modern version. The modern version of the third law is that for every force, there is an equal and opposite counterforce. Would you please underline counterforce? Number 10. A 4 kilogram object gets pushed enough to accelerate at 12 meters per second. What's the force on it? So I use the equation F equals ma. The m is 4. The a is 12. And so the answer is 48 newtons. Number 11, 8 kilogram object on a 3 meter shelf doesn't move for 16 seconds. What's the net force? So F equals ma. We want to know the force, so we're looking for the F. The m is 8. The a, though, it's not moving at all. If it's not moving, it's not accelerating. The a is going to be 0. So the force is 0. Number 12. A 4 Newton force pushes on a 12 kilogram object for 3 seconds. What's the acceleration? So with our equation F equals ma, we're looking for the a. The F is 4. The m is 12. And we're looking for the a. The 3 is not really being used here. So divide both sides by 12, and we get a is equal to 0.33. Number 13. A 10 Newton force accelerates an object for 5 seconds. The acceleration is 5 meters per second. What's the mass? F equals ma. The 10 is the F. The m is what we're looking for. What is the mass? So the m stays a letter. The a is 5. Divide both sides by 5, and we get 2 kilograms for the mass. Number 14. A 4 kilogram object gets pushed enough to accelerate at 12 meters per second. What is the force on it? So F equals ma, and we are looking for the force. So that stays a letter. The m is 4, and the a is 12. Multiply those together, and we get 48 newtons. Number 15. A 16 Newton force pushes on an 8 kilogram object. What's the acceleration? F equals ma. We are looking for the a acceleration. I put 16 in for the F. I put 8 in for the m. The a stays a letter. And I get 2 for the a. Number 16, a 4 Newton force pushes on a 12 kilogram object for 3 seconds. What's the acceleration? F equals ma. The F is 4. The m is 12. We are looking for the a. Divide both sides by 12 and we get a is 0.33. Number 17, a 10 Newton force accelerates an object for 5 seconds. Its acceleration is 5 meters per second squared. What is the mass? So F equals ma. F is 10. M is what we're looking for, what is the mass, and A is 5. So 2 is the mass. A car hits a tree. How would Isaac Newton state the action and reaction? The action is the car pushing on the tree, making the tree limbs shiver and shake and maybe a leaf fall down. The reaction is the tree pushing on the car, making it slow down to a stop, making it crunch into a different shape. Number 19, a bullet flies into a target. According to Newton, what's the action and reaction? The action is the bullet pushing on the target, maybe making the target rip, maybe making the target break. The reaction is the target pushing on the bullet. So the bullet slows down at least, or maybe the bullet stops. Maybe the bullet bends into a new shape. Number 21, the equation for Newton's second law is F equals ma. The thing that's measured in newtons is the force. The thing that's measured in kilograms is the mass. The thing that's measured in meters per second squared is the a. Acceleration has the variable a. Force has the variable f. M is mass. The modern version of the third law is, for every force, there is an equal and opposite counterforce. 5 kilogram object sits stationary for 20 seconds. What's the net force? If it is stationary, that means that there is no acceleration. So F equals ma is going to be 5 kilograms times 0 acceleration, so the force is 0. A 60 Newton force pushes on an 8 kilogram object. What's the acceleration? F equals ma. The F is 16. The m is 8. We're looking for the a. Divide both sides by 8, and we get a is 2.